Yeah, so as a warning, I also have a large distraction here too. Just a little puppy that might just be crying and barking and doing crazy stuff. So if I'm looking over a little bit, that's why. But yeah, so today I have a little presentation that I wanted to do. So to give a little context here, it's about open data. You want to see the puppy? One sec.
This is why I love Go. Open data, gonna change the world. First, the puppy though. Her name's Georgie, right? Oh my god, she's sweet.
Yeah, Georgia.
There we go.
And back to the open data. So yeah, the presentation that we're doing is, or sorry, that I'm doing is about fully about open data. So yeah, to give context, we were at DevCon last week or the week before. I don't know. But we were there, my team at Component, and we did a workshop, a 50-minute workshop on basically using open data to build, to automate on-chain transactions. So using like different, I guess, areas of the Web3 data stack to power on-chain transactions. And so I was gonna present some of that today. And literally right now, we just published the public repo. It's incomplete in the sense that it won't actually run because the portion that I was responsible for is the portion that's not really working. But my colleague did very well on their part. But it'll still give you a rough idea. Yeah, you can see it was pushed to main 4 minutes ago. But it'll still give you a good idea of like what it takes to do all this stuff. The only thing that's missing is like the model that I created. This predictive model is not complete in the sense that it's well, we'll get to that. So I'll just share my screen. And yeah, if anyone has questions, obviously there's not that many of us in here, which is great because we can have like a real discussion around it. So, pipe up anytime. If you want to post in chat, that's great, but you can also unmute.
The one thing that I will also say on this front from a framing perspective is having gone through the Dune dashboards last week and looked at this first level and most accessible level of open data, such as it is, at least if you're a data scientist and are used to using SQL and like thinking about queries in that more traditional way. The question now for this guild is, okay, like we've got a little bit of understanding of like where I can go to find data and what that data might be and some of the problems with it in terms of, is it really up to date? Is it complete? How do I check that? Is it really open? And now it's like, okay, how can we take this data and do stuff with it and have that, in fact, not just like as some kind of analytical tool in a Dune dashboard, which is enormously cool and already a great step forward, but also can I actually use the insights that I am generating from the data to take actions, in this case on-chain? And can I close the loop in that sense? Because that's what's really fascinating about open ecosystems, right? It's not just that like, oh, the information is all available. It's like the information is all available and we can do stuff with it all in the same go without asking for permission. And that's really, really exciting because it allows a degree of agency that is previously rather unimaginable. So that's where we're going today. And that's where this repo will get us, bar some of Christian's puppies problems.
Yeah. We only have one office and it's being used right now. So I would put her in her like area, but then she'll be crying and nobody wants to hear that. So she's going to have to roam free for now and do some crazy things, but that's okay. Okay. So yeah, you can all see my screen.
Yes.
Okay, awesome. So yeah, this is the presentation. So using the graph and Dune to power on-chain action. So, exactly what Andy was saying, kind of taking this to the next level in terms of actionable actions that you can do with the data beyond just dashboarding and kind of more static things. So yeah, I mean, we're not gonna, this was the specific agenda for DevCon. We don't necessarily have to do the breakout session stuff, but that was actually a last minute workaround because the people who are, the Wi-Fi was so bad that people couldn't download all the dependencies. So we had to do, instead of code along, we did breakout session, which worked well because the code didn't fully work. It all worked out, but, and most of you know each other here, so we can skip that part. So yeah, essentially like kicking this off, this is a more comedic slide because this is actually my email. And basically like I got margin called a lot. If there's any Canadians here, they'll recognize Questrade. It's like a brokerage account kind of for trading options and stocks and bonds and whatnot. I'm not a good trader, clearly. As you can see, I got margin called a lot. And so that's partially my motivation for using the graph and the graph and Dune to power on-chain actions, because my skills in trading are not great. And so I want that to be automated, and I want, fixed logic to take that place, so that I don't lose money like this. That being said, you can use this with any on-chain data. You can power any type of on-chain action. It doesn't have to be related to DeFi at all. It can be related to like an on-chain game, NFTs, like really anything that's on-chain. Yeah, okay. And so yeah, this was we're not going to do that part, but so the next part is just like an overview of the Web3 data stack before like we jump into like the specific portions of it. And this is a really nice image that we found a while back. Someone named Andrew Hong 5297 on Twitter posted it. It's a little bit old, so we have like an updated slide next, but with kind of some new things that were added. But yeah, there's really like if you want to break this out, there's three kind of key areas of the Web3 data stack. The first one and the lowest level one is like the interaction and data source layer. And that's like nodes as a service. That's like clients. Shout out to our friends. I'm in Toronto, and there's a really great company called ChainSafe in Toronto. They also have their own clients as well. I believe it's Lodestar. But yeah, this is like if you directly kind of want to start from the ground up and run a full archive node, for example, and do what these data services are already doing. If you want full customization, then the next level is the query and data mapping level. So we went through Dune Analytics last time. Uh-oh, the dog just ran into a room over there. Okay. Flipside crypto. Flipside's a really interesting one as well. You can use Python to do some of the stuff that you do with Dune. And then of course the graph as well. And the graph, you use GraphQL to do that. Sorry, I'm a little distracted. She ran into that room, into the office. And yeah, then there's a few other ones that are interesting. Parsec is actually no code, but it's really great for DeFi. Deep DAO, they have a lot of information on DAOs, lower touch, but might require a little bit of technical skill. And then of course, like the high touch data providers that I think we touched on as well, which, these aren't necessarily open. They generally cost money, but no code and very specific use cases like Nansen token terminal, which is really interesting for seeing like the valuation of different companies in DeFi and NFT companies. And then Chainalysis, then the Etherscans of the world, Covalent, et cetera. Then we added a few more here because they've updated them. I think I have the notes here. Yeah, the Dune released an API, as we said. DeFi Llama is incredible. They ship at a rate that I haven't seen with other data companies in the space. It's very impressive. Covalent is also decentralized, kind of going the graph route. And then David Mihal, he has a company called CryptoStats. It's a public good, completely open data, no cost. That's his sites are, I think, like fees, crypto.fees, L2 fees. He's got a bunch of really interesting sites that are completely free. And then I put spec.dev. It's a really new company that a friend of mine is running. It's a dev tool and public good that just got funded. Very cool because it's trying to create open backends for DeFi protocols using Postgres. So he's basically like merging on-chain data into a Postgres database that can be used as a backend. Very cool company. Ethereum ETL, TrueBlocks, etc. So anyway, that's kind of an overview of some of the things you can play with in the data stack. Some open, some not so much. But the process that we wanted to go through today is basically broken up into 3 categories. So one is the data fetching category, which is like what we touched on last time with Dune. Then is the data processing and modeling. So like what you do with that data. And then the third one is transaction execution. So like automating through your modeling, creating a signal that then triggers a transaction to be executed. And that's the part that I'm not as savvy on, but the code's there and we'll touch on it. So yeah, the specific example that we went through was basically using Python to collect data and write a simple prediction model. So we were pulling the ETH price data from the graph and Dune just to show, 2 different ways that you can do it for free. And then using a autoregressive moving average model to predict price movement. Very naive model, definitely wouldn't recommend using this in practice. But basically, if price goes up, swap USDC to ETH on Uniswap is the on-chain action that we wanted to trigger. Okay, so data fetching. So just some considerations, I guess, before we actually show, the queries themselves. So these are this is the part that my colleague was doing, but I'll try and do it justice. But just there's so many things to consider when fetching data, including the openness of the data, the openness of the transformation functions that you can do on top of that data. Like, for example, with the graph, there's only so much you can do. Generally, you can only they're working on this with like things like substreams, but there's only so much you can do in terms of transforming the data within the graph. You can really only pull on-chain data and maybe like parse it by time and things like that. But anything you want to do after would be after you load the data into an environment, then you can change or you can transform some of the data, but you can't do that directly through the query. Whereas in Dune, you can get a little more creative with that. Then of course, like available fields, the data formats, the chains and protocols that are covered by that data source, and then a few other considerations like flexibility, latency, trust, reliability, all very important depending on your use case. Because the use case that we're talking about here, which is powering a DeFi action on chain, if the trust, reliability, and latency were an issue, or could be tampered with, then that could really, really screw up our transaction, or, it's an attack vector, essentially. That's why the graph is great. It's not great from a latency point of view, but from a trust and reliability point of view, and a security point of view, it's great. Because if we're using the Dune API and then, somehow someone were to alter the signals we're getting from the Dune API, then that could, completely mess up your chain action. So security is an important thought there.
And Christian, why is that difference from the graph?
Well, to my knowledge, it's because the graph is a protocol, and has its own set of it has a decentralized security, I guess, because it's got its own set of validators and its own system that's is a little harder to compromise versus like a centralized data source like Dune. Dune, the attack vector is if you can somehow alter the if you can compromise one centralized source, then you can tamper with the data. Whereas the graph, you'd have to take over a bunch of nodes, and I imagine it would be a more difficult thing to do. I guess like doing a 51% tack on a chain or something like that. That's my limited knowledge, but I believe that would be the case.
Sure. So it's like, because it's interesting for me because there's obviously many different dimensions along which to think of this stuff. And you're right that like, if I'm trying to change data in the graph, it's significantly more difficult than changing it in Dune, which is just like getting access to their database and making some updates if I'm like good enough as a hacker. Whereas, yeah, like doing that with the protocol is significantly more challenging. But if it's like a supply chain injection attack where like I'm just like somehow getting in between you and your endpoints and changing the data that is coming to you, because like, correct me if I'm wrong, when you're fetching data from a subgraph, you're still using like an API endpoint. The point that you're making is that like the data that comes back from that API endpoint is significantly more difficult to tamper with in the graph than it is within Dune. But if somebody man in the middle's you, they're equally vulnerable. Yeah.
Yeah, exactly. Sorry, I'm trying to connect. I think Zoom is a problem. Whatever. Yeah, no, exactly. And that's my knowledge on security is somewhat limited, but I think you explained it a little bit better. Cool. So yeah, those are just some considerations. So the next part is basically just fetching the data. So let's see if we can find it. Actually, I might have the query in here somewhere. So yeah, the Dune query here is what we'll show first. So this was it's a very simple query. There's a table that Dune already has created, which is just prices of specific, well, of ETH specifically, and then there's also ERC20 token prices as well. But there's a table that they've already created that gives you the price of ETH. So we're basically just taking the average price over an hour and the maximum price during that hour, and then the minimum price during that hour, and returning that here over the last 30 days. So we can see 715 rows, not that much data. And then ordering it by most recent. So you can see this was run, it was last run 5 days ago, which is fine for our purposes. And this will be it. So we used a open SDK that is, I believe Dune's okay with it, but it's basically a workaround to paying for the API, or it was before the API existed, to be fair. But it was kind of a workaround to grab data from Dune in a programmatic way. And essentially all you have to do with this SDK is you call this get prices function, and you indicate the query ID. So you can see like, let me move this. You can see here you have a query ID for the specific query that you wrote. So you specify that here, and that's basically it. You grab that, and it returns a JSON in a JSON format. It returns the query that the data from the query. It's limiting in the sense that it's not like programmatic. When I say that, I mean you can't execute the query using this SDK. So in order to like get this data, you'd have to go hit run, then go back here, call get prices again, and then keep doing that. So it's not like a programmatic way to do it. But it's better than nothing. Obviously they're coming out with their API, so if you want to pay 800 USD a month, you could do it in a lot better of a way, but this is kind of the free workaround. Then there's not too much else going on here. Can you hear the crying?
A little. There's a
Okay,
very
okay.
compelling B plot happening, which we're all very excited about. No
That
problem.
one's good.
Go
I'll let it.
You either have the puppy crying or the construction work in Africa. That's your choice. Are there, while we wait for Christian, is there any questions at this point? First, just in terms of setup and general kind of objective on some of the considerations that Christian showed.
No questions. We're good.
Yeah, carry on.
Okay. So yeah, we load the data in the JSON format, and then this is just turning it essentially into a pandas data frame, because the result that it's returned in through JSON is a little weird. It's like a dictionary of a list of dictionaries, and so you just need to unfurl that essentially. And a pandas data frame, just in case anyone doesn't know, it's basically just rows and tables. It's pandas version of, or sorry, Python's version of rows and tables. And yeah, that's pretty much all there is to it. I don't think, yeah, we actually dropped the minimum and maximum because all we really wanted to do was grab the average price over the hour. So there was actually no need for that in the query. So our data set literally just looks like timestamp, and which is by the hour, and then the average price during that hour. That's it. And then the second thing is the graph query. So with this one, we're using the endpoint that we're using is a chain link price subgraph. And this is our pretty simple GraphQL query where we're just grabbing the ETH USD asset pair. So just ETH priced in USD. And then we're grabbing the timestamp as well. And we're grabbing the first 1,000, the most recent 1,000, I guess, data points. So just timestamp and price. So the exact same query that we're then formatting to grab by hour. So these should, in theory, grab the exact same results so that you can kind of look at them and see, how accurate they are, what the differences are. And we can actually see in here that we actually messed this up. You can see that the graph, we grabbed the 23rd and June grabbed the 13th. That was we just grabbed the wrong timestamps, but that's an easy change with the query. You can see initially slight differences is that very weird timestamp that we're getting from Dune, probably just because we're using the SDK that returns like a weird format, but that's easy to format in Python. And then the price decimals are different as well. And they're different because the days are not lining up here, but otherwise we checked and the data was pretty much the same, or at least close enough. Cool. So yeah, that's the data fetching part. So pretty simple. You just write a couple queries and then you load it into your local environment. You don't have to use Python. You can use any language that you want.
Could I distract you for a moment? And
yep.
Seeing as we've looked at Dune already and have some understanding in this guild of what's happening there and why the data is structured somewhat like it is, despite the weird timestamps, and how to kind of write a SQL query and do the thing. But we have not yet looked at the graph or like what subgraphs are or like where to find them. So I don't think you have to give like an entire description of the entire protocol, but if you could just say like what a subgraph is, where I can go and find that chain link one, and like how I might just navigate around the subgraphs to see other interesting things, it would be really cool to take a look at.
Yeah, for sure. So actually what I do is, this is a great open source tool called GraphIQL, which I guess is now this, but if you put in GraphIQL, this will come up. And it's a great way to parse, to call basically GraphQL endpoints. So if you go into a subgraph and you find one that you like, I guess we want a chain link one here. Where's the search? I don't know if I'll be able to find the specific one through searching. Token price feeds. This is probably it. So yeah, you go into the Graph Explorer and you find this. I think it's called the Subgraph Explorer, and through there you can search for different subgraphs, which are basically just collections of they're collecting specific data from very specific smart contracts. So in this case, this is for Chainlink, and specifically token price feeds from Chainlink that are posted on chain by Chainlink. And as you can see, it'll tell you like the network that it's on. It'll give you the query URL so you can call it via API. This is on the actually, is this the central? Sorry, I can't really see all this. 1 second. I'm just checking because there's two services here. There's the decentralized network, and then there's the centralized. Not really a network, I guess, but the centralized service. And they're actually slowly migrating everything from the centralized service to the decentralized network. But we use the centralized one right now because it's free. You don't have to use GRT to pay. However, it will come to a point where you have to use GRT to pay. You basically become a member of the decentralized network, which is great. But obviously, if you want to save money, then you would use the centralized network because it's free. So I think this is actually the centralized.
I think that these are actually the Graph Explorers, right? Like the other one is called hosted, and I think they just curated these. So the other thing also that I just the hosted one is where they initially began. Just in terms of like a little bit more history for some folks here, like there's some important things to note about the difference between something like Dune and something like the Graph. In the early days of Ethereum, everybody really recognized, look, like data in this network is an absolute nightmare to work with because it's not formatted in the way that we might expect. We don't have tools for working with it. It's very difficult to understand what is happening on the network. And so this flurry of work to make things like Etherscan, a good block explorer, to give insights into like what's happening, and then different efforts to try and like make the data accessible. Dune does that by, as we said last week, building this massive table where every smart contract is like its own table. All of the events and logs in that table are the rows, and then all of the contract functions are the columns. And that's like one traditional SQL kind of way of thinking about data in Ethereum. But there are others. In particular, there's the notion of graphs, right? And like graph databases and graph representations of data have become really popular in the last 10 years. GraphQL is like the language that we used for working with that. It's called the graph query language. It provides certain efficiencies over SQL. It allows for us to do in some way like richer representation and work with more data in a more efficient manner than SQL did in particular contexts. And the graph, instead of like building this like massive table of Ethereum transactions, all the stuff that we worked with 2 weeks ago, they were like, let everybody build their own little graph databases for the contracts that they're interested in. And that's what these subgraphs are. You can go and like create like a mini little graph database for the contracts that you care about, Chainlink price feeds or the Uniswap Oracle or like Gitcoin donations or the signature economies, NFTs, and like anything that you like, you can go and just like create a little subgraph and do your thing. And the like interesting aspect of this is they began, as most projects have, by like providing like a hosted and centralized service. So you would just like write the code to say like, this is the contract that I'm interested in, and these are the functions in that contract that I want you to watch, and this is how I want you to label them and store the data. And they would do that for you and provide it for free. But of course, there's no like real business model in that. And so they have been like moving progressively toward decentralization over the years. And, about a year more, maybe 18 months ago, 2 years ago, they launched their fully decentralized network, which has a whole bunch of different actors in it, indexes, curators, users, and others, and have used their token GRT to try and like power this network, incentivize people to store data, incentivize people to index it, incentivize people to serve it, make people pay in GRT to access certain data in the system. So it's like a different approach to Dune, but one that's like proven to be fairly effective up until now. And it's really what's most interesting about this in the context of this guild is that we have both. And that's why I'm so excited about Christian's presentation, because even if you don't understand all of the subtleties of what's happening in Dune and all of the subtleties of what's going on in the graph, both of which are interesting in their own right to learn about, you can use both of them in a pretty straightforward and simple manner to check your data and touch on some of those considerations that Christian was pointing at, in particular, trust and reliability. Like if we're going to be executing on-chain actions to do with DeFi positions or other things that we would like to stay on top of in these 24/7 markets without being absolutely stressed and insane people the whole time, we need to make sure that the systems that we build are trusted and reliable in our own contexts. And the way that we do that is by distributing power, right? You don't just give Dune the power to tell you what reality is. You don't just give the graph the power to tell you what reality is. If there are multiple of these different services that make slightly different assumptions and build slightly different systems, we as the people can use those to create more robust, more resilient systems for ourselves to do the things that we want in our context. And that's really cool. So it's not this guild is not about oh, the graph is the best, or oh, Dune is the best, or oh, go and use Nansen. It's there's so many tools that we have access to, each with their own trade-offs, each with their own perspectives, and each that provide a particular window onto reality. So don't take the window for the total view. Don't be the blind man standing in a room touching on the part of an elephant. It's really cool to be able to demonstrate, hey, with just I don't know, less than 100 lines of Python in both of those files, we can call both of these places, check the data one against the other, manipulate it in our own environments, and then do whatever we want to do.
Yeah, and I'll say as well, you instead of also just relying on other services, you can also, I mean, ultimately you do rely on the blockchain, but you can also be an indexer yourself of the Ethereum blockchain by running an archive node, for example, and fully pull in the data that you want directly with the chain versus relying on these services that are built on top of it that index on your behalf. If you want to go the full mile, I guess, which we're not even doing. But it's definitely an option. And that's the least, that option has the least latency. So, people who are doing, with respect to DeFi, if people are doing high frequency trading or, MEV related things, they're generally indexing their own nodes so that they have immediate access to this data. So that's just one thing to call out as well. Cool. So yeah, thank you for that background on the graph. So back to the tools. So this tool GraphEQL is a great way to take a look at any endpoint, GraphQL endpoint. Oh, this one has an error. But it's a great way to see kind of what or how to build a query. So you can it's a nice visual tool where you can kind of click and choose different I guess pieces of data from the graph that you're looking at, and build a query that way, and then run it and see what it returns. So in this case, well, this is redundant, but we're looking at the different asset pairs. The one that we care about is just ETHUSD, but this is a really fun tool to play around with. Because it helps from a visualization point of view, low touch in terms of code as well. Cool. So back to this. We went through all this. So yeah, those are the two queries. Any other comments there, Andy, or we can move on to the processing?
Yeah, The only other thing that I'll say is in terms of high fidelity MEV users, these kinds of folks who are trying to run really advanced strategies or using this data where latency is really important. and are like indexing the chain themselves and running their own nodes, like be aware that doing that comes with its own cost as well, right?
Oh yeah.
It's not a cheap endeavor to run like an archival node and maintain it to the tip of the chain, because like if you're going to be using like some kind of cloud service to do that, you require like some pretty big and hefty machines which have a high monthly cost, and the storage of like the execution layer on Ethereum at the moment, the old ETH1 chain, it's roughly like 730, 740 gigs, which also doesn't come cheap if you're in the cloud, or if you're running your own hardware, like you have to have like a terabyte SSD and like a beefy machine to manage, and like a good internet connection. So there's always like trade-offs in all of these things. And it's nice to be aware of those things, because I think we were having this discussion with Sparrow and the Culture Guild. Running your own like archival node, running your own full node is about like $500 a month if you're doing it in the cloud, in terms of like storage, compute, and bandwidth costs. So yeah, interesting just to be aware of that. Well, the puppy has disappeared and is definitely found a very juicy cord somewhere.
No, she's passed out next to me.
Okay.
We're safe.
No.
Yeah, also MEV has changed quite a bit too, with the change to proof of stake. I don't know all the details, but it's still definitely expensive to run a full node, archival or not. Cool. So yeah, the next section is, okay, now we've pulled this data into our environment. We've got it into pandas data frames, which is what we want for this exercise. Now we can do stuff with it. So there's a few points here on the types of modeling, but like this is truly like almost infinite in terms of the things that you can do with the data now that, depending on the data, the things you can do with it are endless. So a few examples, again, with respect to DeFi and with respect to what you can do with this ETH USD price feed. So you can do, conditional logic, for example, something like wallet tracking. So you could say, if Andy buys ETH, then, I want to buy ETH as well. Or you could do, okay, something just if else, if this, then that kind of simple conditional logic. Then you can go a little deeper. You can do, machine learning algorithms. You can do time series predictions. You could write a neural network to predict where the price of ETH is going. There's kind of endless things you can do here. For our example, so let's go back to this. Which one is it? I don't remember. Oh, this was actually the JSON of the graph results. So this is what the data actually the raw data looked like that came from the graph. You can see ETHUSD with the price and then the timestamp as well. But anyway, is it main? No, it's not main. Process. Cool. So yeah, here, like this was the part that you just have to import a few different, we already imported pandas, but you have to import a few other, it's not necessary, but for plotting and visualizations, it helps to import some of these good Python libraries like NumPy, Matplotlib, Seaborn. We use it just to visualize some of the results, but it's not necessary, but it definitely helps. So here you can see just 40 lines of code, very simple. What we're doing here is just processing the data and running it through an ARMA model. So we split it into train and test, very simple approach where 80% of the data is the training set and 20% of the data is the test set. And then we basically just run that through a autoregressive moving average model and try and predict the price of ETH, essentially, or the average price of ETH within an hour. The output is, so we just check like the mean squared error just to see how good the model is. It was actually decent, but there's not enough data to affirm that. And then what we're doing here, and this is where this is actually not a fully running model, because we just are predicting on the training set here. So we're not actually predicting into the future. So it's not like a model in production. We're basically predicting stuff that's already happened, and then we're checking it against our test set to see how accurate it was. So if we were to do this in reality, we just have to slightly alter this so that it's predicting an unknown value in the future. And then using that to the result of that to say whether or not we should buy or sell. So that's the tweak that would need to be made here. And then, so we get,
Christian, will you tell us, like earlier you said like autoregressive moving average is like not something you would recommend in production, but you would, now you say also like it was like kind of not actually that bad. And I would just love to hear like you talk a little bit more about like what that means. Is it just like an intuition that you have as like a data scientist? You're like, oh, actually, like that's not bad, or like why is ARMA not like such a great model? And then like why did you say like, oh, actually not so bad? What are you thinking and looking at when you make those kinds of like qualitative calls?
So the only reason I say that is because, and depending, again, I'm not a great data scientist anymore, but one of the things there's various metrics you can use to evaluate the performance of your model. And generally what that is checking, at least in this scenario. So 20%, we left out 20% of the data, and then we pretend it doesn't exist. And then we predict what that 20% of the data is going to look like. So now we have a value of predictions, and then we have the actual data, and we check our predictions against that actual data and see what the difference is. And in this case, the mean squared error is checking like the deviation away from that. And it was actually pretty close. But again, this was only on like 700 data points. There's other ways that you can evaluate the accuracy of the data. But ideally, we would go back to like the beginning of time, the beginning of Ethereum, and run all of that through this data and then see how accurate it is. That's the only reason I say it was decent, is because it had a good mean squared error and it was actually predicting the direction accurately. And this is naive because we're doing all this stuff, but then what we're doing, the signal that we're creating is if the price of ETH is greater. So we're predicting the price of ETH in the next hour, or that's what this should be doing, predicting the price of ETH in the next hour. And we're checking to see, okay, is that greater or less than the last hour? And if the price of ETH in the next hour is greater than the price of ETH right now, then we will buy. So even if it's like 0.1 higher, we'll still buy. And so that's why this thing kind of seems like it's accurate, but it's actually not great. So this is why. So you can see the real values. This is the one in red. And our prediction is the green. So you can't really tell here, but it's slightly declining. And because the green line, our predictions are slightly declining, we're actually predicting this correctly because it is going down. So we would be selling in this case or not buying. But you can see like it's really not an accurate depiction of where the price went, but because it's going slightly down and the actual price of ETH did go down, it technically is correct. Does that make sense?
We're all about good enough at Kernel. It's good enough.
Yeah, exactly. So yeah, it's like you run the model and then you have to create an output. And then that output generally will be like a binary thing, like buy or sell. I'm sure you can have more options, but this is the signal, like returning true or false. That's a signal that will then pick up and use to execute it on chain, or to execute some sort of transaction, or maybe not execute a transaction based on that result. So yeah, again, this is the result. So this is a part where I am not an expert whatsoever, but we'll go over it anyway. So now we have a signal. We grabbed all the data through Dune and the graph. We did a model that creates a signal saying true or false. And based on it being true, that means we would buy. If it's false, then I think we just hold in this case. I don't think we sell. But it's as simple as that. All of that distills down to just a true or false. So there's tons of considerations here, because this is the part that is most important, because you're actually executing a transaction. You want this to be secure. You want to think of different attack vectors. So my colleague Matthias is the one who wrote through all this stuff, but a few of the things that he wrote. So considering what chains you're operating on, is it adversarial? So is a transaction that you're going to do, is it something that can be attacked, right? Front run. Should you be using different methods to avoid a sandwich attack or being front run, depending on the amount of money that you're working with? What kind of timeline you're operating on, which goes back to latency. One issue that you could run into here is if you're using the graph, and this is a kind of a complex issue, which I don't have a full grasp on, but say you get a signal, you're executing a transaction based off of data in the past. And by the time that you're executing the transaction, that data might be old, which means when you're doing like a buy or a sell, for example, if that requires specific parameters, those parameters might be incorrect by the time you're executing the transaction, which would basically mean like you get an error, a transaction error, because for example, say it doesn't necessarily apply to buying or selling ETH, but say you're providing liquidity somewhere, and that requires a specific balance between ETH and USDC. If the data that you're operating off of tells you you need to have a specific balance of ETH and USDC, then you would get like a price impact error if that data is old and the price has changed enough that that the parameters that you told the smart contract to do don't work anymore. That's where we talk about like the timeline that you're operating on, depending on the action that you're doing. That's about as far as my knowledge goes, but you have to make sure that the data that you're operating off of is from that to, or the signal to transaction time is short enough that it's something that won't change like extremely rapidly, like block to block. That's where you need kind of that high frequency stream of data. And then, yeah, key management, very important. If you were to run this in reality, who's managing these keys? Is it a multi-sig? What are the things that require you to actually execute the transaction, or is it fully automated? He had some comments on this that I don't really remember. So I think, yeah, the private key for this was being stored in a config file, but there are probably better ways to go about that. Then, of course, should your logic be transparent? So like if everyone can see your transactions and your logic openly, there's different things that could happen. People could copy it, front run you, etc. And then what we were talking about here, what if the transaction fails or it's congested? You have to set parameters maybe in advance around when you might want to execute and then when you might not want to. Again, I'm not an expert on this stuff, but these are some considerations that he was talking about. And then options for this stuff. So there's different transaction libraries. So Ether's Web3.js, you could do it through the cloud. You could do it on your local machine. There's keeper networks, which are interesting, but I don't know that much about. But this is a very key topic because using on or off chain logic is depending on who you talk to, is a controversial thing, because here we're using off chain logic because the modeling that we're doing is all, and like the transformations that we're doing of the data is all off chain. Whereas something like Yearn, they're only using on chain data. They're not doing anything off chain. All the signals are on the blockchain, and then the transactions are on the blockchain. Everything stays on chain. Whereas here we're bringing stuff off chain. We're creating a signal off chain, and then we're bringing it back on chain. A lot of people want to avoid that for security reasons, mainly. Then, yeah, transaction execution services, an Oracle. You might be using an Oracle for various things. You might want to create your own Oracle using a multi-sig and then the builder API to avoid things like MEV. These are just some options that would require further research from me to fully explain.
It's fascinating to like hear and begin to dig into some of these things, because like when we paint the conceptual picture of like we have a world of open data, it's not very structured. There's like a lot of services that you can use to get it into a form that you can actually like reasonably fetch, use, model, and transform yourself, and then use the outputs of your own work to like re-enter the public and adversarial ledger and do whatever it is that you want to do based on your own insights. Like that sounds really wonderful. And now this is where like the rubber meets the road, so to speak, because they like doing this kind of stuff, particularly in an adversarial and public environment, is really, really interesting. It's fascinating for me to have like sat on like the sidelines of this for such a long time, and to have watched the exponential increase in capability and effectiveness, or just general skill of like the population as like these tools have taken hold. And it really is a testament to the power of open source networks, and particularly like open source economic networks, because now all of a sudden like the development in the complexity of strategies both on and off chain has led to this explosion of like new kinds of tools and knowledge, which some of which are listed on the slide. The keepers and like key management are probably like two of the interesting ones, but in general, like strategies on chain or off chain are fascinating to look at. You can find some really, really interesting ones if you follow some of the like Flashbots people, but comes to mind in particular, and often will point to particular contracts on chain that have obscured their logic to the greatest extent possible. It's not totally possible if you like are like a shadowy supercoder, but for like the majority of us, even if you can read Solidity, these kinds of like trading bots that are put on chain are really, really difficult to decode, because they are specifically crafted to do that if you are going to go like the on-chain option. If you're going to go the off-chain option, then like it's interesting to recognize the number of things that you have to be aware of. And while it's wonderful to work in teams like Christian is, and to have people like Matthias around you to navigate and understand some of these subtleties, like being aware that like there is such a thing as a keeper, and the role of the keeper, generally speaking, if you look at like Maker or Yearn, where are the two major places where these things are used, is to like perform certain critical actions that need to be automated in order for the contracts to go on running, like updating the price feeds and these kinds of things, because you know, executing transactions on chain that require a certain understanding of time without enabling awkward permissions is very, very difficult. And it speaks to the conceptual boundary between like what is on chain and what is off chain, and like analyzing like that is such an interesting way to understand both like the promise and interesting aspects of blockchains, but also their limitations, right? Because like how does data get on chain and who manages it is a fascinating question, but I'll stop because of the drawing.
Yeah, no, that's a really good point. Like anyone can put data on chain in theory. It doesn't make it trustworthy. I could create an oracle right now of when my dog takes a nap. Is that trustworthy? It's hard to say. So there's also that conundrum as well. Cool. So this is pretty much the end of it. You have the code here for the transaction. So again, well, not that much code. So this is using web3.py, and we're using Goerli. We're grabbing the Uniswap contract through the ABI, and we're the contract that, or sorry, yeah, the function that we're using through the Uniswap contract is the swap function, where we only care about the USD WETH. That's the swap that we want to do, is USDC for WETH if if the signal says bye, basically, or if our function returns true. So just swapping USDC for WEAF. And that's as far as my knowledge goes, but it's quite a simple thing in reality in terms of code, not considering all the things that we talked about before, which is really what makes it complicated, not the function itself, just the ways that it can be exploited, or considerations for security and privacy. Those are the things that really complicate it. And then the last thing, I guess, is I think this is so this is actually a shill for our project, which is a product we're coming out with called Blueprint. But basically, it's the fact that this is the only thing that you would actually need to do to a certain extent. You have to do some of the modeling yourself, like figure out like what logic you want to use. But everything else in terms of data aggregation and in terms of execution and solidity, our product Blueprint abstracts that away, so that all you have to focus on is the logic. And this is basically the extent of the code that you would have to write. It's not out yet, but that's just something that we mentioned in our presentation, something that we're working on. Yeah, I think that's it. Yeah. Cool.
Thank you so much. It's lovely to see the whole process and to get some brief little tangential insights into other things to learn about as we try and figure out, okay, like data is now open, what can we do with it? And that to me is like, it's as always, like one of the most exciting parts of any of these discussions for me is that it's not just about freedom, for instance. It's like, if you have systems that enable freedom inherently by virtue of their architecture and the intentionality with which they have been written and implemented, then the question becomes, what can we do with freedom? Freedom is not an end in itself, it's a means. And like asking what that end is and moving towards it is where the really generative, interesting, and often difficult discussions are, because that's where nuance and complexity and all of this stuff sits. And it's the same thing with data. It's like, okay, great. Like I can talk until I'm blue in the face about agolmias and pleasing gifts and what it means to really think about this stuff in terms of how we might share our time more valuably with one another. But like here is where it really like begins to meet the road in terms of thinking like, okay, we have access to so much more data than has ever been the case, not just within blockchains, but particularly here in these kinds of networks. And like, what can we do with it? What can we do with it as a community and as a community of practice and use? That seems to me really, really fascinating. So thank you so much for being willing to present all of this with the puppy and sans Matthias. It's brave. And the other thing that I really appreciate about this is that Christian is an expert, but it's really wonderful to come across somebody who's also like, I don't know about like this stuff. Because what I love to see and what I hope it illustrates in general for a lot of us is that like you just start somewhere, because like none of us know all of it, and that's the great joy, in fact, and the great opportunity of so much of this technology is that like the whole point is that nobody knows all of it, and that's really exciting, and it's liberating, in fact, when you get past the anxiety of the ego that wants to know everything and be completely coherent and present a polished professional surface that is like, yes, you can hire me, and hopefully we're moving past those kinds of things as we do more and more of these kinds of sessions and look at this stuff together. So we have a few more minutes for questions. Does anybody have anything burning that is really? Ryan, please.
This is a question for, I guess, the group, and it's the the elephant in the room that Andy was touching on. But so right now we're talking about open data, and the examples are, like ETH pricing and this kind of stuff, like financialized transactions and stuff like that. But jumping off of our Stigmergent people call from last week, which is about how can we utilize data to contextualize and bring about human wisdom and whatnot. My question to the group, and I touched on this on Friday, and the Stigmergent thing is asking this questions of like, all right, what can we do with this open data versus like, what should we do with this open data? I'm just trying to understand and kind of look into the future of like, how can this be co-opted and be maliciously used, and how can good intentions from a handful of developers potentially create something that's very, very destructive. So I'm just posing that question of like, how do we try to act and build these tools around freedom and whatnot versus, yeah, I don't know. And I guess the mindset there is like, we're all coming out of a place of like, the MVP, just come up with an idea, get it out there, get it out in front of customers, find your market, product market fit and all this kind of stuff. But does that need to change in building these open data tools, specifically when they come down to like social interactions and people, people's identity and stuff like that? So where's that line between getting out there, building an MVP, iterating over time versus, I don't know, where's that line? And I'm constantly asking myself this question, and I kind of went off on Friday on the Stigmergent people, like kind of preaching and yelling at myself. Yeah, asking the same question. But what do you guys think? Where's that line? How do we go about building these open data tools, especially on the social side of things, with the responsibility to have to look into the future and figure out how things can potentially be used maliciously and whatnot?
Thank you very much. Yaji?
That was a great question. Actually, I kind of similar thought. This whole I guess the demo from Christian kind of remind me of my first data science project, doing the stock a prediction for the pricing of the whatever stock in there, trying to do just a basic regression analysis on there and just predicting the price. But after so many studies on those, found out that the stock price, and doesn't matter whatever model you're using, whatever analysis you're using, you just almost never really get that right from the basic data science approach. And I kind of feel similar thing with a lot of the data we see in this crypto market. If you're just purely looking for price and making a financial gain, I feel maybe a lot of those the things that we are doing may not doing as much, just kind of doing the bot in the stock market. This is a similar kind of idea for the crypto. Kind of, I thought about if this is a purely open data, maybe the use of data can be something kind of in a bad way. You can checking the sanction, you can checking how you want to, if people did some if some government doesn't want you to send money to a certain places or something like that. I feel this is the type of the place they can get in fairly easily. But I would just kind of give me a lot of different ideas.
Wonderful. Yeah. So that's the idea of these skills, Brad.
Yeah, answering Ryan's question maybe a little. I mean, I don't have any great answers. I'm mostly been working in Web 2 and thinking of it in terms of graph data, largely kleptoparasited from social services like Twitter and LinkedIn, which have this graph data. So-and-so is connected to so-and-so, so-and-so retweeted so-and-so, that's in their silos, but we can get them either legitimately through APIs like Twitter's API. So that data is there, and it's kind of owned by the silos, and some of it can be got through APIs. And then so my question is, and I can see ways of mirroring an edge like from A to B that we got from Twitter, like so-and-so retweeted so-and-so, or so-and-so marked so-and-so. We can put that into a graph database in Web 2. And then I've just been thinking of it as, okay, how do we mirror that edge using one of these Web 3 protocols like Lens, or I just shared this one I discovered yesterday, mem.co. So that doesn't address your questions, Ryan, about privacy and how we want to control use. It's basically the same problems you have in Web 2, I think. Well, actually, it is a little bit more fraught, because when everything's decentralized and open, it's very difficult to enforce, except through contracts, I guess. So, I mean, I'm definitely not the expert on how to do that in Web 3, but I would think that we have a combination of more potential because of the decentralization, and potentially more controllable through, software contracts. I don't know if that helps.
Yeah, that helps. The thing that haunts me is like the problem that we're trying to solve against, like, the powers that be, the Amazons, the Googles, it's like 20 years from now, are we going to be saying like, oh, society was so much more fill in the blank, civil, peaceful, whatever, when our identities and data was protected by just a handful of companies. And now look at what's happened, that anybody
And
can be
that's
a Google,
actually,
anybody's an AI, it's crazy to think about.
that's actually the big vision from my perspective that I haven't really talked about here yet, is that, there's no reason why we couldn't own our own social graph. I mean, a social graph that, if you just think about what's the kernel social graph, right? Kernel should own that social graph, and it should be able to govern it as a DAO with liquid democracy and control access to it. And then why just kernel? Why not kernel and adjacent possible, right? I mean, that I think is the big opportunity, is that there is no such thing as a social graph that owns itself yet. And I think that this technology makes it possible for sure.
Thank you, both. I think that's, if anybody needs to leave, please feel free to, because I know that this is the end of the scheduled time that we have. I will say like a few things here. Also, Christian, I wonder if you have any thoughts on these ideas. The first is that these words control, force, seem to me at odds with, or even ownership, seem to me at odds with the real interesting parts of these technologies. And I have explored some of those ideas in signature economies and elsewhere. I don't think that social graph is like a very interesting or general way of navigating some of the concerns. And I certainly don't think that like the enforcement or the control or the ownership of that is something that's like kernel would pursue, for instance. But in general, like one of the points that I do want to make, and it's somewhat related to what Fotis is saying in the chat, is like the question is like, can public blockchains in principle avoid capture? And I know Fotis's perspective on this. Mine differs slightly, and I think has often been accused of sort of a certain kind of naivety, which may indeed be true. But I think that there's room for some nuance here, which is like worth exploring, because while this model that we've gone through today is exceptionally toy-like, and certainly nothing that you would ever run in production. And it does remind us of like the first data model that you do on buying stocks or this kind of stuff. And Yaji, you're exactly right that, you know, like it doesn't actually bear much relationship to reality at all. What's fascinating about it is that you, like, everybody has access to these things. And as I think about that, you know, like one of the interesting aspects of everybody running HFT models and neural networks and these kinds of things on like the current stock markets is that they have these like self-fulfilling prophetic natures. So the more people that run these kinds of models, which are trained in certain kinds of ways, the more it amplifies certain kinds of behavior in the stock market, which is fascinating to perceive, because these markets are reflections of collective sentiments or belief, which is fascinating. They're really mirrors of ourselves in many ways, but they're not fully mirrors of ourselves because they're not accessible and they're not readily understood by like large parts of the population outside of those with certain kinds of privilege and access. So I think that like that is a first step toward like thinking more deeply about like why it is interesting in terms of the media in which these things are occurring to like have like similar approaches to the data science that currently happens on stock markets, but in a place where there is no owner, where there is no enforcement, right? The great promise, and Christian, if you need to leave and attend to the puppy, thank you so much. The great promise of these things is that like it's not about force. Language is executed independent of recourse to force. Now, can such environments in principle avoid capture? I happen to think like yes, with the addition of like layer 1 or layer 0 like privacy tools, however you want to cut it that way, which I think is underway in pretty much all of the major chains. And the reason that I think that is because we understand recuperation really quite well, actually. Recuperation is a Marxist term that is deployed to try and capture and describe the ways in which capitalist systems are able to recuperate criticisms of them and turn them into that which drives the capitalist machine. The best example of this kind of thing is perhaps something like Occupy, where like you have this like upwelling of popular criticism of capitalism, and then like the machine recuperates many of those criticisms and turns them into, you know, unique little brand off markets, hipster stores in Brooklyn and premium mediocre and these kinds of things. Or another example of this is the old hacker labs. This is a fascinating one for me. Hacker labs were these spaces that were started by people on the edge of society, squatting in abandoned buildings and then like hacking in those arenas, because that's really like a big part of the actual like critique and the actual activism involved in hacking, right? And then this becomes like an increasingly popular activity, such that all of a sudden people begin to create hacker spaces. And hacker spaces are radically different, because what happens is like the Camden Port Authority, for instance, goes and buys all of the abandoned buildings, employs rent agencies to kick the squatters out, and then those rent agencies turn around and rent the spaces back to people who host hacker spaces, paying for the same place where Hacker Labs used to be, but in a much more bougie way, right? And like this is recuperation. These are the many examples of this kind of thing. And the way in which we counter those kinds of movements from larger market forces is like three-pronged, right? Like it's technical skill, it's shared values, and it's collective memory. The hacker spaces one is an interesting example of the failure of collective memory in those spaces themselves. The obfuscation of it by like large-scale capitalist forces. And I think that, yeah, like when we're aware of these things, we can find like a really generative middle ground between genuine openness and transparency, because there is something truly valuable about that, which is like not fully thought through in the critique of like so-called solarpunk imaginations of blockchains, because that this like openness and the ability for anybody to participate is absolutely critical. It's absolutely critical. And then if that is balanced, then this is where a lot of work needs to be done. This is where I really do agree with Photos, that like it has to be balanced by like privacy for like individuals, and that needs to be not like some add-on. It needs to be at the base layer, because that enables the kind of environment and the kind of medium that is truly resistant to recuperation, precisely because it allows for the practice of increasingly better technical skills, which we've already seen happening. It allows for the cultivation of shared values outside of the spotlight of like surveillance capitalism, which is something that we haven't yet seen. And it allows for collective memory, which is inherently a part of the medium. So, yeah, I'm happy to go on.
Andy, definitely would like to have a longer conversation about the whole, self-owning social graph concept, because I want to understand your resistance to it, and also kind of just talk about what I see as the potential value. And I think it does actually play into the sort of privacy / community control, in the sense that well, I'm thinking, like, let's say that kernel we mark each other within kernel, and kernel's penumbra is what I call it, the 1 degree separation of people who aren't kernel but are related, right? Where do those marks go, and who has access to those marks, right? And there's value in those marks, right? So how does that value accrue to the community in a way that Facebook, it's all of its value is derived from its social graph, right? So how would the community essentially offer that social graph to apps?
Yeah.
I actually have to go soon, but yeah, Andy.
Wonderful. We can continue this. We can continue this.
Definitely interested in talking about it more.
Thank you.
I got
so
around.
much. Thank you, everybody.